Welcome to Brain Vision.
Okay, so since there's only one axis and one inlet, so we have m dot in is equal to m dot out. If we expand it, we have m dot 1 plus m dot 2 is equal to m dot 3. M dot 1 here is the mass flow rate for the cold stream. M dot 2 here is the mass flow rate for the hot stream. And M dot 3 here is the mass flow rate for the mixture. So in the question, it was saying that the mass flow rate of the cold stream is twice as a hot one. So therefore, I have m dot 1 is equal to 2 m dot 2. If we plug in back to the equation, eventually we'll have 3 m dot 2 is equal to m dot 3. So now let's take a look at the energy balance equation. In this case, we know the rate of change in internal energy, kinetic energy, and the potential energy is 0. So we have E dot in is equal to E dot out. If we expand it, we have m dot 1 H1 plus m dot 2 H2 is equal to m dot 3 H3. H1 here is the enthalpy for the cold stream. H2 here is the enthalpies for the hot stream. Okay, and H3 here is the enthalpy for the mixture. And remember, before such calculation here, we have 3m2 dot is equal to m3 dot, and m1 dot is equal to m2 dot. So therefore, we can use m2 dot to substitute for m1 and m3 in this case. So we have 2m2 dot times h1 plus m2 dot times h2 is equal to 3m2 dot h3. As you can tell, m2 dot can be cancelled off. And this will give us 2h1 plus h2 is equal to 3h3, which means that h3 is equal to 2h1 over 3 plus 1 over 3 times h2. Okay, so now let's use the table at the back of the book, which is the saturated refrigerants 134A table. Okay, so at temperature equal to 20 degrees Celsius, we'll have the corresponding enthalpy is 79.32 kilojoule per kilogram. And then at temperature equal to 80 degrees Celsius and the pressure equal to 1 megapascal, we'll have the corresponding enthalpy is 314.25 kilojoule per kilogram. So now we can determine H3. If we plug in values, eventually we'll have the H3 is equal to 157.63 kilojoule per kilogram. So now let's assume the mixture is also having the same pressure, which is 1 megapascal. So now if we take a look at the table, we'll have the enthalpy, which is the enthalpy of a saturated liquid, which is given as 107.32 kilojoule per kilogram. Okay, and also the enthalpy of a saturated vapor refrigerant 134A, which is, I'm sorry, not saturated vapor, is enthalpy of the evaporation of refrigerants 134A, which is the H3FG here. Okay, is equal to 163.67 kilojoule per kilogram. So now we can determine the quality of the exceeding stream. Okay, which is equal to, so we have H3 is equal to H3F plus X times H3 FG. So if we do some arrangement, eventually you'll have X is equal to H3 minus H3F over H3FG. If we plug in the values, eventually you have the quality is about 0.307. So also at such pressure, we'll find a corresponding saturated temperature for the refrigerants 134A is 39.37 degrees Celsius. Okay, and these are the answers for this question.